I would like to talk about your lab test 1 briefly, which is going to happen not this Friday, but next Friday, right? Just make sure it's marked on your calendar. I want to speak a little bit about it. You should have received some forum posts last week, just about some birthday book example that you can look into. I want to point a little bit more to it. Hopefully that will also help you get better prepared. For lab test 1, basically 2 main things you have to master, or we expect you to master. 2 things, okay? Number 1, you should know about the birthday book example, which I'm going to talk about today. I'll make sure I cover that thoroughly. And there are actually 2 versions of the code that's available to you. They look 95% similar, okay? Just some details a little bit different. For version number 1, you can definitely just go to our lecture site, and then you will see over here, specifying a birthday book using the math models, specifically function. That's one version here. Another version is what the other sections instructors send out the forum. It's on the GitHub. That's second version. Look at both. Okay? They are not that different, but they do have some little discrepancies you can learn from. Okay, that's about the birthday book, which I'll cover in details today. And you should be familiar with the math models. Specifically, make sure you know about relation, make sure you know about functions, and pair, specifically. Okay, so these classes. And possibly either towards the end of today or Wednesday, I'll start talking about our first design pattern. It's called iterator. That's also covered in your lab test 1. And for this one here, I would suggest you still have about 10 days before your actual lab test. Your best bet is to really get familiar with programming with this particular pattern, given that you only got 80 minutes in the lab test. Your best preparation will be look into 2 tutorial videos, which I recorded previously. Look at them. I'll show you how to get them. If you go to the lecture site, okay, for 3311, and then you will see that over here, so there are 2 things over here. So one is called generic parameters and iterator. I'll make it bigger. So one is called generic parameter and the iterator pattern. The other one is called information hiding and the iterator pattern. They are a little bit long, but I would suggest plan your time to actually watch them and also do the exercises for that. That should really get you prepared for iterator. This Friday, I know you got your lab number 2 due, but I believe most of you should be doing well. But I will try to do a little bit in-lab demo on the iterator pattern to help you. Okay, hopefully that can also help for your lab test 1. All right, any question about lab test 1? Everybody is okay? Go ahead. Yeah, it's going to be run in lab test mode, so you have no access to the internet. No, you're alone, basically. I don't think there will be any files available to you. For now, assume no. So you will be given a little bit starter code, and then you can get started from there. So that's why getting familiar with iterator pattern and birthday book will be the best preparation. Yeah. Yeah, use math model, yes, for lab test 1. Correct. Yes, question? We don't really have sample lab tests, but I would suggest when you look at the birthday book, it's very similar to what you're going to see in the lab test. Basically, I would suggest the following. I will make it a little bit more elaborate as I go through the birthday book. Once you download the birthday book example, get rid of all the implementation contracts. So that's kind of the starter project you'll be given, maybe. And then start from scratch and time yourself, maybe for 60 minutes, so you can also get 20 minutes to write some additional tests. That's how I would suggest. That the format will be very similar. There should be no surprise in terms of the formats. You don't really have to create new clusters, and you don't have to fiddle with the ESF file. You don't have to. Okay? You may have to create new classes or new features, maybe. Okay, lab test 1, we're going to make some written guide, but possibly it will only come around Thursday. So for now, your best preparation is to study the birthday book and also study the tutorial videos for iterator. That will be my suggestion. Okay, if you got questions, let me know. I would like to, first of all, talk about one particular feature in the math model. So it's called the overridden or override feature. Okay, let's take a quick look because you might need. It come out quite often. Okay. The query version is simply called overridden. okay? And you will also see from the relation class, okay, so I would suggest go to the relation class in math model and look over to see one is called override. So that's the command version. And overridden is a query version, which will be immutable and return you a relation. I just want to talk very briefly about how it can be computed. Okay, let's see this. One way to think about it, even though I don't quite recommend, but if that might help. Recall what you learned back in 2030 about hash table, right? How do you conceptualize a hash table? It's more like a two-column table. Let's say we have a very simple table. Let's say we have a table that looks like this. We got two columns over here, and of course one will be the key, and the other one will be the value, let's say, for example. And then let's say we simply got from string into integer, just make it easy. So we may have Alan over here, Mark, and then Tom. Let's say 1, 2, and 3. I simply got a hash table where the keys are simply strings. Of course, they should be unique. There should be no duplicates. And also the values is simply just integer, right? As a hash table. Now, override goes a little bit like this. Tell me something. I'm going to give you two method calls on this particular table. Let's say this is simply table T, like a hash table. Assuming that I've done all the creation already, assuming that. If I say T.put, okay? In Java convention, you put a key value first and then value. But in iPhone, it's the opposite. Just be careful when you do the lab test. If I simply say, for example, Jim, okay, it's a string, and then I say 4, for example, versus if I say T.put, I'm calling the same method. And then I'll simply say Mark over here, and then let's say 7. So I got number 1 here and number 2 here. First of all, if I try to run these two method calls, am I going to get any runtime exceptions in Java? Yes? No? I guess no, because they're both valid. However, what's really the fundamental difference between these two method calls, really? A hint for you, look at the key values. Anybody? Yes? Yes, exactly. That's exactly the difference. Let me repeat that. The fundamental difference is this. Jim over here is not an existing key. You can see Jim doesn't really exist as a key in the table. On the other hand, Mark over here is an existing key, positive. And apparently the put command or the put method does not require the key to exist. Okay, that's something to note. The reason I'm mentioning this is maybe for some of you who might be very used to a hash table, it's easier for you to draw a connection to. Now, what's the consequence of executing 1? 1 is actually quite easy. In that case, you can Jim doesn't exist. It's as if we try to add a new row over here. I simply put Jim here, and I put 4. Okay? Now, the interesting bit is about number 2. What about number 2? If Mark already exists as an existing key, what should we do with it? Jordan, any thought? Oh, I'm just asking. That's fine. If you have an answer.
Don't they usually put it in like a bucket or something like that?
You're talking about like a bucket array that way. No, no bucket.
Like a hash, like when you have a hash table, usually they like it's the same.
I would say for this particular illustration, you don't have to worry about bucket array. We don't have to worry about hashing. Nothing to do with hashing. That's okay. Anybody? Yes.
We just replace the 2 with 7.
Yes, exactly. So now in this case, if you're in my 2030 class, I would say the easiest way for you to think about when a key actually exists already, you will simply replace the corresponding value over here just by the new value. Okay? That's how you can think of it. But now, I would like to make it a 2-step process for you because that can link a little bit better to the mathematical overriding operator that I want to carry through. When I have this particular one, okay, let's say, let me highlight it, okay? So this is the one I'm talking about over here. Mark already exists. So now you can think about the following, okay? Number 1, we have to do a domain subtraction. Domain subtraction on mark, which is the key that actually already exists. So what does this really mean? It's just a fancy way of saying just get rid of this row. That's step number one. Okay? And step number two is to union the map with the new entry. In this case, it will be mark and then followed by 7. It's like an entry. So now we are just adding a new row. Conceptually, that's how you can think of it. Doesn't really mean you have to create a new row. Just easier to think that way. So now it will be mark and then 7. So mark remain to be an existing key, but just the value is a bit different, right? So rather than 2, it's now 7. Okay, any question about these two scenarios about the put? Questions? You definitely can think of that way, but I'm just saying, when you actually see a mathematical definition for override, which I'm going to show in just a minute, you will actually see 2 steps. I'm just trying to make it more synchronized with that view. Right? You can definitely think of you just keep the same row and then replace the value. That's fine too. Right? I'm just saying it's easier to think. Yeah. Okay, any questions? Yes, exactly true. So you can think about the keys in a hash table are like domain for the relation or function. And values in a hash table is like a range in your relation function. And that's something you want to get comfortable with. Okay, good. Okay, that's good. So now let me go back. Having this warm up, let's go back to our overridden. I'll just mention quickly. You can definitely read the slides. I don't need to waste your time over here. So now let's say the following. If I have a relation that goes like this, okay? Let's say this is my relation here. I call it R. And then it simply got A1, B2, C3, etc. Okay? So let's say that's my relation. Okay? It's just a set of pairs, like a hash table. You can think about A maps to 1, B maps to 2, and etc. So now, if I want to do overwrite or overridden, depending on you want to use command or the query, depends. Let's say I want to say R overridden with, so now when you do overridden in math models, you're allowed to actually put just not a single entry, but you can put a set of entries. So that's a slight extension. You can put a set of entries. So now we're saying the following. We're saying that we got A3 and C4, okay? So now, what can we think about this? The way to think about this is going to, first of all, return a new relation, right? This is immutable query, so it's going to return a new relation, first of all. And now, it would be very useful to think about in 2 steps, as I mentioned. Remember the 2 steps? Let me review quickly. First of all, do a domain subtraction, which means get rid of all the pairs in the relation where the domain values match the one you're looking for. Step number 1. And then you're going to union with whatever pairs you want to get into. Okay, let's see that. So now we're simply saying A3 and C4. So what domain restriction should I do? It should be restricted to a subtraction, sorry. So be careful the distinction between subtraction and restriction, they're different, okay? What I meant to say was subtraction, okay? Let's do a domain subtraction on A and C. So now think about this particular relation here. I'm going to get rid of all the pairs where the domain is A or C. Get rid of this, get rid of this. That's the first step. And then after that, I'm going to add in A3 and C4. So after this, I'm going to insert A3 and also C4. So you can think about this as more like the case for mark that we talk about in the hash table. That's override. Guys, any questions about overriding for relation? You will need that. Okay, that's why I really want to make sure everybody's okay. Yes? You can think about overriding is more like a 2-step process. In the first step, you try to remove. You want to remove all the pairs whose domain values are matching, whatever the pairs you're trying to insert into. And then the second step, you're trying to put things in. So 2 steps. Maybe what you're confused about is this. Let me just talk about quickly, right? But All other things about domain restriction, domain subtraction, that's something you have to review carefully. Okay, you can speak to me during the office hour if you wish, but we're not doing that in the class. Let me try to understand what your question might be. In the relation class, there is a it's maybe called override. I think it's called override. Override is a command which will simply take a set of pairs, basically. I'm just sketching a little bit. And we got another one called overridden. This one, the input parameter is exactly the same. We're also taking a set of pairs. Okay, something, you can look up the exact signature. But now this guy here is going to return just another relation. And then with generic parameter, I believe G and H, something like that. So the difference between these two are as follows. Let's review very quickly. If I say r.override, for example, over here, and by putting some set of pairs, in this case, this is a command call, which does not call anything, does not return anything. So the consequence is you cannot use this, not to be used in contracts. If you simply call override like this, it's not going to return anything, so it cannot be used in the contract, number one. Okay? On the other hand, if I say r.overridden, and then this one here is an expression, so I can keep building on top. For example, I might say, after doing the overridden, what would be the domain? And this will be just a set of something. Okay, that's something to remind you. In the lab test, you want to make sure these concepts are clear to you. Okay. Any question about override versus overridden? Yes. Yeah. There you go. Yes, basically you think about algorithmically, right? What you will do is you're going to go over every pair over here. For every pair, look at the domain value. If the domain value is either A or C, you want to get rid of them for the first step. And then the second step, you're going to add in A3 and C4 as the two new pairs. That's how you do it. Yes, exactly. So now, let's say when you look at this particular expression in the over here in the slides, so after calling this, the new relation you will get reads like this: A3, B2, B5, C4, D1, E2, and F3. That's basically what you will have. Oh, how did you initiate the original relation? Uh-huh. Okay, let me get your question straight. Are you talking about how to create R to begin with?
Right, because we have more than one gains.
More than one? Oh, that's definitely fine. Because remember R, okay, let me show you this. So now if you also look at the test in the slides, right? First of all, we declare R to be a relation where the domain is string and range is integer. Okay? And then one way to create it is to say create R.make from tuple array. So that means I can just simply pass in as many pairs as I like. You can somehow get rid of something. You also got other commands or query that can also remove. You can look over them. Yeah, override is one of them. Yes, exactly. So you can see over here. Okay, let's just summarize quickly. So you can see for this original R, you can see for domain value A is mapping to 1, 4, and that's it. Okay. So now after the overriding, so now because we want to override it with A3, for example, that means you want to get rid of A1 and A4 and only keep A3. Exactly. Right. That's overriding. Right. Yes. Oh, that's an interesting question. Yes, exactly right. So the question was, let me put it here. Let me just try to get to over here. Okay, just a new one. The question was like this. What if I say R dot overridden, for example? And then, so now, let's say I just want to put, let's say A100. And then I put just another one, A200, for example. Just array, right? Just happen to be two things. First of all, this is absolutely valid. That's allowed. It's a set because you can see these two items over here. One was with 100, the other one is 200. So they're actually different. So what's going to happen is, if I may try to duplicate the relation for you, so that will help. Okay. Can I simply just copy this and put it here? And then can I possibly get it smaller? There we go. Okay. Let's say that's a relation, right? Let's see how we can do it quickly. So now you can see, first of all, we have to remove. So now here we only worry about getting rid of A in the first step. So that means you will still get rid of A here, and then adding in basically A100 and also A200. So that will be the new relation. Yeah. As long as you're passing a set, even a singleton set, that's fine. Okay. Oh, that's okay. It's actually okay to be more than 2A because R is a relation. It's not a function, right? So when you actually got, so now I would suggest you want to really know what's the difference between relation versus function. Relation is saying for every domain value, for example, D1, it may map to an arbitrary set of values in the range, right? It may map to maybe range 1 and range 2. It's absolutely allowed. But what about function? For function here, it's saying for every domain value, you can map to at most one value. Okay? For example, you might only map to R1, something like that. But I would suggest if you still have confusion, maybe try to look at the review part of the lecture here and then come back to me. That'll be easier.
So if we were to do 1A though, overridden, but still would be 2B.
Yes, the idea, so that's why I would like to describe the overridden as a two-step process. The first step, you want to do a domain subtraction. You subtract all the pairs with the domain value A. Do that first. Doesn't matter how many are involved. And then the second step, you try to do the union. Yeah, all right? Yeah, it's consistent with what you learned in 2090. I'm not creating something new. Okay. Question? Yeah, override. Yeah, you can think about override, overridden. They're basically doing identical operation. Override changes the context object. Overridden returns a new thing without changing the context objects. Right? Okay. All right, everybody happy? Overridden, again, is very important, not just for lab test, but also for your understanding. Okay, so that's why it's worth talking about it. After overriding, I would like to give you one exercise to think about, and then we're going to do it together. That will also help you write contracts for birthday book a little bit later. We'll get there. Let me explain to you what we are trying to do for this particular exercise here. I'll do some example in just a moment. Let me just explain the feature. So we're basically talking about a query. All positive values. It's going to take one input as an array of integer. The array may or may not be empty. Okay? It's also going to return another array of integer, which may or may not be empty. Okay? Just taking an array, returning another array. Now, the required clause, which we'll try to do it together, is to say the input array contains no duplicates. For example, like this. Let's say this. If I try to call all positive values, and then let's say -1 doesn't have to be sorted. It does not have to be sorted. It can be random. Let's say -7, 2, and then 1, and then 10. Okay, you can see there's no duplicates over here. Right? So that will satisfy the precondition. But I got to know how to write it. But we'll get to that in just a moment. If I try to call the feature here, what it's going to return is just another array. And the array is going to contain all the positive larger than 0 numbers in the input array. In this case, it's going to give to me 2, 1, and 10. In whatever order, doesn't matter. You can think about input array is just like a set, and output array is just like another set. That's the query we have. Okay? And our goal is, first of all, let's do the precondition together. Okay? After that, I would like you to consider if given the client satisfy the precondition, is the current postcondition enough? Okay, that's something we'll get into. But let's just do the first part. We want to make sure there is no duplicates over here in the input array. In the precondition, you don't have to worry about the relation between the pre and post state. It's only the pre-states in the precondition. So in some ways, it's simpler. But now, how do we know that there's no duplicates? Well, I'm pretty sure you solve problem like this in 1022, but in a way using for loop or while loop. But now we want to turn that into possibly across expressions, right? Yes? But maybe not overridden, because overridden is only for math models like a relation. So now in this case, it's an array. So overridden doesn't apply here. Think about what you have. You got across. You can either across the array of A, or you can across the indices, right, of A. Any idea? Jordan?
So we can do 2 across loops.
You mean 2 parallel or nested?
So nested.
Nested, okay.
So we can go through the, like from 1 to the count of the array.
Yep.
As x, or sorry, is x. And then same thing for, like, for the nested loop, we can do an across loop from 1 to the count for y.
Yeah.
And then we can say x not equal y implies that the array at x is not the array.
Wow, that's pretty good. Yeah, that's exactly how you should do it. But before I put it down, let's see what the intuition is. I'm pretty sure you have seen this in 1022, so it's not a hard problem. Okay, just remind you quickly. If I got my array that looks like this, for example, let's say this is my input array. Let's say that is my input. Let me give you one example where there is duplicates. -1, let's say -1 is here, for example, and 2, 4, and then 1, and then 3. Apparently there is duplicates, right? But how do you show these are duplicates? Basically, you want to do like a pairwise comparison, right, for the indices, for the elements. This is 0, okay, indices. Let's say 0, 1, 2, 3, 4, 5. We want to have a way to actually compare, compare 0 to 1, 0 to 2, 0 to 3, right? All the pairwise comparison, right? It will be more like an n square complexity as you learn. So now, as long as we can show that for a particular pair of indices, for example, let's say this is A, you can see, first of all, 0 is not equal to 3, the indices, right? That means there are different cells in the array. On the other hand, you can see A0 is not equal to A3. Oh, sorry, equal to, beg your pardon. So having these, so that would mean you have duplicates. Okay? You are basically in different locations of your array, you actually got the same element, in this case, -1. That's what you have to do. Questions? Okay, hopefully that wouldn't bother you too much, right? No, actually for contracts, you know what? I think for contracts, you want to aim for clarity and simplicity. Efficiency is your second concern. Yeah, good. Plus there's no, I think that's overkill if you try to use hash set. I'm not sure if that's even doable.
Are we allowed to, like, even have objects in our postcondition?
Have objects? What do you mean have objects?
Like, I don't know that we're able to have, like, variables in our postcondition.
The only variable, okay, what can you refer to in a postcondition in general? Okay, let me just talk about it. It's more like a summary of what we have learned so far. Under the ensure clause, where you mean precondition or postcondition? Oh, let me put both. Okay. Let's say under precondition, okay, basically what can you put over here? you can put some attributes in the current class, or you can put maybe some calls to some queries. And then you can, for the require, okay, what can you not refer to? Number one, you cannot refer to local variables. I'll explain this in just a moment. And also, you cannot use the O keyword.
I mean, I guess.
In some way, saying O keyword conceptually is not wrong, but it's redundant because everything in the precondition, when you check it, is pre-states. So
I
you
was
don't.
just wondering because he was suggesting using like a hash map or something, or like a hash table.
But we don't need to use hash table. We don't need
Well,
to
I
be
guess
bothered
you
by
could
that.
write like a function that returns a boolean. I was Yeah.
Okay, for now, ensure over here, of course, you can also refer to attributes. You can also refer to any calls to the queries. And again, you cannot use local variables. And however, you can use O keyword. Right? Make sure you're clear with that. There's no cheat sheets for you for lab test 1. So make sure you're clear with that. Let me explain one more thing before I take your question. We want to understand why you are not supposed to use local variables over here. Okay? Think about the way you lay out your feature. If you say feature F, typically you would say require, and then you say local, right? Local should go after the require. And then you would say do something here, and then ensure, and then end. The way to think about this is you can think about from local until the do part. So this is the implementation. On the other hand, so here require and whatever is under require and whatever is under ensure. So that should be the contracts, the specification, right? So now local is just part of the details for the implementation, and the user should not be bothered with that, especially the clients. That's why local variables should not appear over there. Okay? If you try that, you're going to get compilation error. Questions?
Yeah, I'm wondering, can we use math models and require?
Yes, you can definitely use math models in any of the contracts. It can be precondition, can be postcondition, can also be invariants. Yes, but not in the implementation. Okay. Right. Let me give you a little bit further hints about how to write the precondition quickly, and then we have to move on to the postcondition. So now for the precondition over here, no duplicates, right? You definitely need some nested loop to actually get a pairwise comparison. You want to say across, the first across maybe from 1, assuming that the indices will be from 1. Okay, remember that's in iPhone. Okay, just for the language specific details. And then maybe from 1 until A that counts. And then you can put it all over here. You can put it all in the next line. Doesn't matter. Okay. You can think about this is the first level, which will I forgot one thing, is I, assuming that I is not declared previously. So you can think about this is the first level, which I will be bound from 1 until A count. Okay. For example, 1 to 5. We want another nested level. This guy over here is going to be the body of the across all loop. So this is expecting something that can return a Boolean. And now an across all loop can just return a Boolean. So that's why it can just be the body of another across loop. So what I can put here is across 1 until A that counts is, for example, J. So it's a different dummy variable I'm introducing. And then put all here and then end. So now I can use both I and J in here. So now we'll do something very similar to what I just illustrated to say, basically for any pairwise comparison you're doing, okay, any one here, you want to make sure, first of all, if the indices are different, I would care to look further, because if the indices are simply just the same, of course their value will be the same. We're just looking at the same location. So now, if I'm looking at different locations, and also their value also happen to be the same, of course I got duplicates. Okay. So now what you should put over here, I'll put it here. What you should put here, basically, okay, I'll just put it here. I'm running out of space. You should have something like an implies. Okay, so now no duplicates means if basically I'll put in English, you translate it, distinct locations implies distinct values. Right? So if this happens to be false, that means you have duplicates. Okay? You can fill in the blanks. Can.
You would like reduce the number of iterations of an interval by more than half, and you can simplify the comparison if you just run across
Uh-huh.
plus one.
Yeah, I agree with you. Yeah. What Ken just suggested was very clever. I'll write it down first, right? But this one works, first of all, right? Ken was suggesting the following. I thought I was expecting somebody to actually suggest that, given that you've been programming quite a lot. Are you suggesting to say here, rather than 1, I'm going to say possibly I plus 1. This one, I believe, also works, and you can try to convince yourself. However, as I said, this is only going to be executed in the context of contracts, where efficiency is not our concern, right? But it's got to be n squared anyway, right? You're suggesting we can just do 1 across loop. How? While we're checking the same array has no duplicates, right? You know what? What you're thinking is like this. I wouldn't mind. However, that's a little bit overkill. Okay? What you're thinking is like this. I'll just talk about this, and then we should go to the postcondition. I think what you're thinking is more like this. As I go over the array like this, right? If I'm currently looking at position I may want to make sure I does not somehow exist in this particular, in this particular subarray, I believe. So it will still end up being like an n squared time, but I would say that's a little bit hard to specify. So I think a nested cross loop will be fine. Question?
I believe in an array there is a feature called occurrence. We can just cross ones and occurrence equals 1.
Current?
Occurrence. There's a feature.
Oh, the currents, yes. But remember, depending on how we ask you, right? So what your colleague just suggested was you can look into this particular feature in the array called occurrences. I think is it occurrence or occurrence, right? Okay. So guys, look into this particular feature if you wish in the array class called occurrence. Basically, it's counting how many times a particular element exists in the array. Of course, if the array contains no duplicates, then every element has occurrence 1. That's another way to write it. However, depending on how we constrain you in the lab test or the exam, we might say you cannot make any helper feature call. In that case, you have to rely on logic. Depends. Yeah, but I would say it's a good solution if you're doing a project or a lab. Yeah. Okay, let's now go back to our main focus, postcondition. Everybody knows pretty well how this is supposed to do, what this is supposed to do. I want you to look at this particular postcondition over here. Let's say this is your exam question, very likely. Okay. Let's say you already did part A about writing the contract for no duplicates as a precondition. Part B goes like this. Is the current postcondition complete in the sense that any errors from the supplier can be caught? If you don't believe so, can you give one example where the postcondition will be happy, meaning that it will be evaluated true, but something wrong has happened? Right.
Maybe you forgot to add one positive element.
You mean the postcondition?
Yeah. So you're making sure that all of them are positive, but maybe you have one that you forgot to add to the
Okay, that's good. That's good. That's pretty good. Okay, let me just write it down, and then if you got anything to add, let's see. Okay, first of all, we should understand that this is incomplete, for example. Okay, let's say this. That's pretty good. Because the intuition is, this is saying everything in the result should be positive. I'll go a little bit more extreme. What if all the positive numbers in the result has nothing to do with the original array? They're just positive. You see what I mean? Okay, but pretty much the same thought. Let's say this is the original array over here. Let's say -2, -7, 2, 1, and 10. And then let's say the result we are trying to return goes like this. We are expecting, let's say, two positive numbers. We're expecting three positive numbers. But now I just give you something random, 101, 202, and 303. Right? It's completely wrong. Is the current postcondition going to evaluate the true? It is. So that's not a good postcondition. It's getting something to be done. For example, if somehow if the result mistakenly get maybe -1, you can catch such error, but it's not enough, not complete. So this is the kind of exercise you want to get used to. I give you something like a design, you want to criticize on that. If you don't believe the design is good, give me a counterexample, and then we'll read through your explanation. Okay, for this particular, I'm going to start a new page and then talk about it. So now this will be wrong implementation, of course, but the postcondition will evaluate to true. Okay, that's the problem. Okay. What I would do now is I'm going to copy this guy here, and then we'll try to see what should you write then to be complete. Maybe I'll put it here. Okay. Okay, postcondition. Any idea? What should we put? Ken?
You could do two processes. The first one could just make sure that the result is a subset of A, and then the second one could go across A and check if it's positive.
Okay, I do hear you, but I'll hold that a little bit. That's basically what I wanted to hear. Okay, that's fine. Any other thoughts you want to contribute? You want to say something?
Why can't you just go across the whole array and see all the values within the results?
Well, what you're suggesting is like this. If I, let me say this. You're saying that, why don't I simply go across A and to make sure every element there is in the result?
Yes.
Is that right? What if you got negative in the array? Should that also be in the result?
Oh, but also checking that.
Yeah, exactly. Okay. So let me start with this. Okay, that's a good first step. Okay. So what I would suggest is let's forget about this particular incomplete. Let's start from scratch. Okay. What you're saying is this. If you have basically this, imagine that this is the set of element that's in A. Okay. In the array. Let's say the order is not important, which you may got positive, you also may got negative, right? There's a subset over there, which are the positive number. We want to make sure, basically, what you're saying, this particular subset, every element in the subset is actually in the result. That's what you're saying. Okay? How do we write this? Do I really need indices over here? Do I need to go across the indices, or I need to go across the array? Would that be sufficient? Let me just go across the array. You can think about to yourself is whether going across the indices will really be necessary. Think about that issue here. Okay. Okay. First of all, let me give a meaningful tag. I would say all positive in A. Sorry, it's a bit long. Also in result. Okay. So now what I can do is across A, which is the array, is integer, let's say n, is a number, okay? And what you were suggesting originally, okay, let me put it down first. I can simply write, let's say, result, which is an array. Result has. This one here is apparently wrong, because what if n happens to be negative, right? We didn't say anything about the input array cannot contain negative. So that means not necessarily everything in A should be in the result. For example, maybe there's some elements over here that is negative. That shouldn't be there, right? So now, any suggestion to complete this? Yes? If statements, I don't object to it, but I would suggest better style. If you write if statements, This is what you have to write, first of all. Okay, let me write it down. You're basically saying if what, first of all? If n is positive, yes, I'll write it first. Okay, result dot has n. Can you just close it by saying and? I don't think you can. If you try to use if then else as an expression, it's a syntactic requirements that you should always get if and else. You should specify both cases. Okay? Now, oh, maybe you didn't know that, right? Be careful. It's good that I mentioned this before your lab test. Don't try this, right, if you forgot. Now, I have a question for you, first of all. If I just try this, right, and then I would say else, I'm obliged syntactically to put something over here. What should I put? Hmm? Yeah, what you're saying is not result dot has n. I wouldn't say that's wrong, but I would say there's a better thing to have. Yes. Yeah, Jordan, us, so many. Okay, go ahead.
You go ahead first, because my question.
Go ahead.
Isn't n the index?
No, n over here. Remember we said go across A, the array. So n is going to be some elements in the in A.
No, we're using is, right? So isn't n an index?
No, when you say is, yeah, when you say so when you say is over here, it simply tells you whatever dummy variable you have over here is going to store some member of the collection. This is a collection of integers, right? It's an array of integer. So that's why n will just be an integer. On the other hand, if you put s over here, in that case, n will not be just an integer. It will be a cursor to integer, in which case you have to say n dot item, right? That's something we said previously. Yeah, be careful, okay? Okay? Okay, good. Now, this one is not too bad, but I would suggest something possibly is even better, okay? Huh? Implies is even better, but let me tell you why, okay? Think about logically what we are trying to do here. We're basically saying, we're saying all positive, if that's really the positive in A, we're only worried about if they are in result or not. We'll have other postcondition to ensure something else. So for separation of concern, for this current postcondition, we want to say if the positive number is in A, it should be in result. Nothing else we should worry about. So this guy here may not be so necessary conceptually. Okay? So now I would suggest one thing here. Let's say we don't want this. You could put true. I'll explain why you can say true here in just a moment. Okay? Of course, you don't put t, you put true, right? Programmatically. And now let's say how we can use implies. If you think about how you can use implies, you will simply say n larger than 0 implies result, or just say r dot has n. That's all you have to write, right? The nice thing about this particular implication is you're saying the following. If the antecedent is actually true, then I care to evaluate the consequence. If the antecedent is simply not true, which means n is not positive, I simply don't care. I rely on something else to help me later. Okay? But if you really put it if then else, that's also fine. It's not wrong. I'm just saying it's not as ideal.
So you're checking, so you're basically saying separate the word and check for the negative number in a different.
We will see something like that. We will see something like that. Yeah. So what the current postcondition is doing is like this. Imagine that if this is the set of elements that's returned from the result. Okay, the green one is the result. And then again, this big set over here is the input array A. Only conceptually a subset, the orange part, is actually positive. We want to make sure every element here is an element here. That's what we are doing. Okay, that's the first one. Okay, let me call that postcondition 1 over here. Is that enough? No, here we don't really need to worry about the modification. Here we just want to worry about whether the array you actually return is actually containing all the positive numbers from the input array A. That's all we care. So we don't worry about modification here. Yeah? Oh, actually, in this case, swapping element is allowed because all we care is whether the array you're returning contain all the positive elements. So you can think about the input and output, they are more like a set. That's what you can think about. Okay? Guys, any flaw to here? And hint to you, how do you prove two sets are equivalents? Did you realize we are doing one step, one of the two steps to make sure two sets are equivalents? Yeah, want to say something? Yeah.
Make sure their duplicate value.
For duplicates, we'll worry about duplicate in just a moment. Let's just worry about whether they actually contain the same set of elements. We'll worry about duplicate in just a moment. Alan.
So we have to worry about that it contains all the positive values, not just like some of them.
No, actually, this way here, okay, what you're phrasing is actually not gonna, what you're worried about is not gonna happen. Basically, we're saying this. Here, for this across loop, we're saying everything that's in the positive subset over here, everything here is in result. It's guaranteed to contain that. So that's not a concern.
And then how do we know that it's all like,
So basically, we're saying all positive numbers over here are basically here. That's what we are asserting, right? If there's anything,
I'm just saying like maybe it's missing some of the positive values of the
nope, you cannot miss because we're going across A. We're saying that as long as it's not positive, it must be in the result. If not, it will be false. So everything that's here should be here. We'll put it this way: this set here is at least as big as this set here. I'm already giving you a hint. You may want to check the other way, but now tell me something. Okay, I think it's really worth doing this in more detail. Okay, let me just put this one here, and then I will simply put, okay, this is something we don't want, right, from the original one. And over here, we're saying across, let me write it quickly, okay? Across A is n all. N larger than 0 implies result dot has n, okay? This is our first postcondition. It seems like the postcondition may not be complete, but if you do believe there is incomplete, can you give me one scenario where it is problematic, but the postcondition will evaluate to true? Jordan.
So the elements of A could have changed in the body of the method, and so then even though it appears that our like result has a positive number,
I would say, in order for us to simplify this a little bit, we usually assume that you don't try to change parameter. Yeah. Okay. Let me write that assumption just to otherwise there will be many other possibilities. Okay. Let's assume. Okay. A as a parameter is not modified. That's what we can assume. But even that, this postcondition is still incomplete. Yeah, go ahead.
Result is the superset of A.
Yeah, if the result is a superset of A. That's exactly right. So basically, this is the example you're supposed to construct to make your point, okay? This is incomplete. First of all, it alone, okay? Because, for example, let's say this is A, okay? Oh, you know what? I'll make it very simple. Let's say 2 minus 1 and 3. Okay? And the result, let's say, goes like this. You definitely get 2 and 3. You also get 1, 4, 4. Now, is this particular scenario problematic, first of all? It is problematic because including something that's not supposed to be there, 1, 4, 4. 1, 4, 4 is not supposed to be there, first of all. Right? Okay? Should not be here. On the other hand, is the postcondition good enough to catch this? Now really, because it's only saying Everything in the A that's positive, 2 is positive, is there. -1, don't care. 3, positive, is there. That's it. Nothing to check against 1, 4, 4. Okay? So now what we should do now is to say the other way. So that's why I want to remind you something you learned from 2090. I wouldn't go to the proof of that, don't worry. Just remind you the fact, right? If I got 2 sets, S and T, how do I prove the 2 sets are equivalent, right? Basically, S should be a subset of T, and also T should be a subset of S. Right? These are the 2 things you got to prove. So now think of S over here is all the positive numbers in A, and T is the result. Think that way. And now we want to prove it, right? The first postcondition we just write out was this one here. Okay, this one here is to make sure all positive. Oh, sorry, that's not the one. Let me just write down this guy here. Sorry. This one here is basically saying each positive number in A is also in result. And this one here is to make sure each number in result is also in A. You may want to say a little bit more. Each number in result is positive and also in A, possibly, right? To be safe. Okay, any question here?
But they should be equivalent. They should, like, 'cause
I'm just saying conceptually, let's think about, even though the 2 are array, that's why we might need another postcondition. We might need, but let's bear with that just for now.
The
Yes.
same way you remove the positive, the check for thing on the first way.
Uh-huh.
Why are you checking is positive? Because there shouldn't be any positive in result, and if there is, that should be a different case.
Are you mainly worried about this particular one? You mean here?
I just realized,
Okay, that's fine, that's fine. Guys, any question? The reason I really want to talk about this is you might see the same similar problem appearing in different shape or different context. So the truth, so how can you master this kind of problem? If the return value of your query is actually a certain collection, it can be a set, can be a linked list, can be like a hash table, whatever, okay? So now, somehow you want to write a complete contract for the return collection. And you want to make sure you actually prove the equivalence of the collection against the expected value. That's why you want to prove the equivalence between 2 sets. Okay? Try to get comfortable with this pattern here, or speak to me. Okay? Okay, let's complete it. And then I will have another question for you. I know it takes a long time, but it's important. Okay? And then once we get to BirthdayBook, you'll be quick. Okay? Not too much to address logically. Okay, so now I want to go for just one more, okay? So now, let's see this. I would just say all positive in A, also in the result. Okay, this one is something we are comfortable with. I would say across A is number n, or n larger than 0 implies, and then I can say result dot has n. Okay, that's the first one. And then we want to say all number in result also is in A, right? The opposite direction. We can say across result is n. Or now we can say, first of all, n should be larger than 0. Just make sure it's positive, right? It should only return positive. In some way, this already talk about this here, right? You can incorporate that already, okay? But you don't need to specify this explicitly. And, okay, should be that A dot has. Now, question, important. There might be a part C, right? Green one combined with red one, pink one. It seems that we are proving equivalence between two sets, or two arrays, conceptually as a set, maybe. So now, back to the fact that the resulting array, the result might be an array. It's not really a set, right? Do you think green and pink together are really complete? I heard no. Who said no? I heard yes. Are you trying to say the which one? You mean the input has duplicates or the result have duplicate? Okay, sure. That's actually the answer. So green and pink together, unfortunately, are not complete just yet. Okay. And now, how can we prove that, right? I need a witness to disprove this, right? To witness, I need a witness to give, I want a result so that something problematic occurred, but the postcondition evaluated true, basically, right? Let me put it here. I want a witness. Let's say A looks like this. Let's make it very simple. -1 and also 2, just like that, right? And now let's say result over here, 2 and 2. Is this problematic? Indeed, because array allow duplicate. It shouldn't have duplicate. Conceptually, they should be a set, right? You should not have duplicates, first of all. It's problematic because you got duplicates in the output array, number one. Number two, is this particular scenario going to make the two postconditions happy? They're going to, right? They'll run very quickly, right? If you check for this one here, basically -1, don't care, 2 is in here. Okay, that's the first one. Okay, when I check for this one here, basically, okay, go over, 2 is positive, also is in here. 2 is positive, also in here. Right? So it seems like it will make both postconditions true. Now, what should we write? Seems to be the final one.
Just copy the precondition and
Oh yeah,
change
absolutely, I agree with you. Somehow you can reuse your code if you did it correctly for the precondition, yes. So now, I'll put it down and then there'll be an exercise for you. Now complete, so now the resolution to it is another postcondition to say no duplicates in result. Okay, now exercise for you. Okay, try that. There's one more thing I want to mention before I take any of your questions. The reason that we needed this particular postcondition here, simply because the input and output data structure, they are simply linear, which will allow duplicates. That's why we have to look after those scenarios. On the other hand, if the problem you're given will simply give you maybe just a set, in that case, it's guaranteed by definition set do not have any duplicates. In that case, you do not need this particular postcondition. I want to mention quickly. Okay? Yeah. Let me just undo it so you can still get the clean solution. Guys, any question? You can see basically for this particular example, study that very carefully. What's given over here originally, we said it's not complete, and then we go gradually by adding this, by adding that, and then by adding that. You should understand for each addition to see why we should do so, right? Yes? We did already, because you can see over here, the question was, should we also check to see every number in the result is positive? We did that already. Right? Yeah. I would say, sure, if you really want to separate that, that's fine. But I would say you can just incorporate that as a conjunction here too. That's fine. Either way, it's fine. Yeah. All right. If no question, okay, let's go back to birthday book. Okay. Okay, for the birthday book, let me just go over quickly, and then we have to understand certain constructs, okay? We can definitely finish that within the first 15 minutes next class, but let's see how much we can do before the end of today, okay? Okay, so birthday book, you really want to study that carefully, not just for lab tests, but for your understanding about a more complicated scenario for using math models. Okay, it's going to be a collection of entries. Each entry will be a name and a birthday, right? And then, so now, like a hash table, no two entries in the book are allowed to have the same name. Name will be the search key, so that's why they should be unique, okay? And then each birthday will be a month and day. So if for version number 1, we have a class called birthday. In version number 2 in the GitHub, there's another version of birthday, in which case we use something for doing static methods or static queries in iPhone. You can look at that too. Okay, you should know both. But for the class example, we just use the non-static version. Okay, a birthday. So now initially birthday book is just empty. Okay, you got different operations. Okay. This is one possible birthday book. Let's say we got basically 4 entries. We got Alan, Mark, Tom, and Jim, and we got 3 possible birthdays. Let's say, right? We got the different mappings. So now, what about the different operations? I'll do that. I'll sketch quickly, and then we'll make it precise. First of all, how the number of entries currently stored in the book, like a count, right? In this case, the count will just be 4, right? 1, 2, 3, 4. 4 mappings. That one's easy. I want to add a new entry. So now, add a new entry is similar to put in the hash table, which is also similar to override in math models, right? That's why I talk about overriding in the beginning. So when you say you want to put a new entry, for example, here, if I want to put a birthday, for example, for Simon, versus putting a birthday for Jim, they should mean different things, right? You can see Simon is not an existing key in the birthday book. In that case, I'm adding a new mapping, basically, a new pair. On the other hand, Jim already exists. I'm basically changing this to something else, right? That's basically put. But there's something we have to be careful when we specify the contracts, but we'll get there. How do you remove entry associated with a person? Well, that's easy. If I want to remove Alan, just remove this particular mapping, right? Easy. And then find the birthday of a particular person. So now this one here is more like a lookup. What's the birthday for Mark? Well, in that case, you map to a single one, which is August 11. Remember, we decided we're going to use a function as opposed to relation to model a birthday book, because each person should map to just a single birthday. Okay. So now for the next one, I'm going to clear this a little bit to make it precise to you. Okay. There's another feature there that's slightly more, not really complicated, just slightly harder. Get a reminder list of names of people who share a given birthday. So what do I mean? For this particular book, okay, let's say this is the birthday book in my app. So now I want to say book.remind. I want to know which of my friends actually were born in August 11. So I can do something. It's like given a range value. I want to know what are the domain values that are associated with them. It's like a reverse lookup, right? In this case, that should give me a set, right? So now, that's why I talk about that postcondition for so long. Well, I was preparing you for that, okay? So now it should be Mark and Tom. What about if I say book.remind? And for example, I might say November 29th. What would that be? Empty? Agree? Yeah, you always got a case of empty, right? Conceptually empty set. Of course, empty array or empty list depends on the data structure. Okay, that's good. So these are all the operations for the birthday book, right? That's not complicated, but you want to be careful. So now we have to make some decisions before we talk about the design, okay? What kind of decision? First of all, design decision, okay? Design decision. First of all, should we use, what classes should we use? Maybe we should use one class for birthday and one class for birthday book. You shouldn't put birthday and birthday book into a single class. So that'd be so-called a Superman class. That's not a good design. We'll talk a little bit more about this kind of design issue later when we talk about inheritance. Okay, what clauses should you need? And then client-supplier versus inheritance. Client-supplier simply means should we declare an attribute of, for example, hash table? Or should we let maybe birthday inherits from hashable, something like that, right? What should be the architecture? And then what mathematical model should we use for the birthday book? We discussed that it should be a relation, it should be a function as opposed to a relation. Remember the justification, that's important, okay? You may have to make a similar justification later. Contracts, okay? We want to know what contract should we write. I think logically you are totally ready, right? Given the exercise we did just a few moments ago. Implementation decision, let me mention that briefly. It's not exactly the scope for this course, let's just mention that in the context. So now you may implement using two linear data structure, array and linked list. In that case, there'll be a linear time, right, for the lookup. How can we do better? Well, apparently if you use hash table, if assuming that your hash function is pretty well defined, so that would mean you can close the constant time at the runtime, right? Is it possible to do somewhere between constant and linear? You can use a tree. You want to be more precise here? What kind of tree?
So a self-balancing binary search tree.
Ah, self-balancing binary search tree. Pretty good. Basically, balancing is really important. If you only say, I'm going to use a binary search tree to implement my birthday book, it's no guarantee it's going to be logged in. It has to be balanced. Okay? Well, something to remind you, in 2011. So this is kind of the slide that's simulating what you have to work as a software engineer later, right? You think about what design level, what kind of details should I look after, also for the implementation. Okay, and then once you have this, let's say in the example, you will see using a hash table, right? It's pretty efficient implementation, but now external clients, when they look at the contract view of your classes, they only want to see model. And the model is going to be a function. How do you write contracts for remind, put, count, etc. using a mathematical function? That's a challenge. Okay. Good. Okay, I'm going to go over a little bit. I got about 7 minutes or so. Okay, let's see as much as we can do. And then we get to iterator for sure on Wednesday. Okay, for the design, starting from lab number 3, you will have to draw some bound diagram. And maybe in the exam, not the exam, sorry. Starting from lab 3 and lab 4 and also the project, you will have to draw bound diagram. I'm going to talk a little bit more about how, the syntax, but this already slides made available to you in the beginning of the semester. You should really start going over them a little bit. That will prepare you for later labs. Let's go over quickly. Basically, here we talk about 3 classes. We talk about birthday book, we talk about birthday, and also we talk about name. Okay? For the birthday class, we got day and month. And then we have the class variant to say, in order for your birthday object to be valid, the month should be between 1 and 12, and the day should be between 1 and 31. So this is actually not very exactly correct, right? What if I got February 31st, right? So the invariant is not exactly catching what you need, but it's doing something. But if you look to see version number 2 in the GitHub, it shows you how you can do some validation. Okay, look at that. Okay. But for the purpose of illustration, we'll look at this version here. So we got birthday here, and then we also got name. So now the name here, rather than using a string, if you simply say every name in the birthday, every name in a birthday book is simply just a string, you have some trouble. But what if the string is simply something like this? Maybe @hash_. This cannot be a valid name, can it? So the intention is you to simply define a class called name. And then you want to make sure somehow one step towards making that correct is by saying we have an invariant for this particular name. And the first character, for example, must be some lexical alphabets, basically. Okay, so we're using name as opposed to string. There's a reason for that, right? Because every time you create your own class, you can put class invariants there to put more relevant constraint. Okay, so now I want to tell you something about how you can draw diagram quickly. Okay, let's say for the design here, I declare for the birthday book, right? So now I talk about design. So this is more from the view of the clients of your birthday book. The client is going to see my model over here is of type function. So fun is actually from the math models, okay? The domain is the name, okay? That's the domain. And birthday is the range, domain and range, okay? In your design diagram, you may actually want to show some association or show some client-supplier relation over here. What I meant by this was, when you look at this particular decoration over here, okay, let me clear that a little bit, so make it clear. When you look at this particular line here, you can see function over here is the supplier. More precisely, we got 3 suppliers over here. You got a supplier called function, you got a supplier called name, you also got a supplier called birthday. You got 3 suppliers. So now, which supplier class you actually want to show in details is kind of up to you as a designer, right? Let's say we decide to show the one of the supplier, which is birthday. Let's say we want to do that, okay? Now, that's why I put a birthday over here. So birthday is just another class, which is the supplier for my birthday book, because in my birthday book, I declare my attribute using it. How do I draw the client-supplier arrow between them? Okay. Again, the rule would be go from clients to supplier, right? The birthday book is the clients. And the birthday over here is the supplier. And then I simply draw some green arrow over here. So the software I use is something you're required to use as well later. It's called draw.io. But if you look at the slides, you will see that reference. It's a free tool online. Okay? So we simply draw a green arrow over here, but now what's important is what kind of label should you put on the green arrow? Okay? First of all, we put the name of the supplier, which is model here. Because model was declared to be function of name and birthday. I'm showing birthday specifically. So that's why I put model here, but now this is something I blew out. Okay? What should I put over there? Well, you should put the supplier's name and also their type. So you would think you should put something like this. You will simply put function, right, where the domain is the name. And then the range should be just running out of space, birthday. Does it make sense to you up to now? Okay. However, that's not 100% correct because you do have some redundancy over here. The redundancy goes like this. This arrow over here already tells you the supplier is birthday. Why do you have to repeat birthday again? Because the arrow already suggests who the supplier is. So now there is a there's a syntax you want to use. If I'm already pointing to this particular birthday class, I have to use ... Okay, that's some syntax you want to get used to get 4 marks. So if I reveal the blue box over here, that's what you will see. Okay, you can see function here, and then name, and also ... right? It's talking about birthday. Okay, guys, make sense? Okay, of course you can still say birthday there. You just wouldn't get 4 marks if that's what you're concerned about. I'm just trying to tell you what's the rationale of putting ... Okay, let's do some exercise here. Let's say typically in your particular class, you might have multiple or many supplier relations. You don't have to show all of them. You only select those you think that's relevant to your clients to show. In this case, I already showed you one, which is about the model. Let's say I want to show you another one. Okay. Let's talk about, I'll talk about this and then we're done. Okay. A couple of minutes. Let's say I got my remind query over here, and then I'm using D of type birthday. So birthday here is also a supplier. Okay, but I may not show it. I may or may not. And also, it is returning an array of name. Here, array is also a supplier. name is also a supplier. So now I got 3 more supplier I may show. Okay, let's say I choose to show the name. Okay, sorry, I choose to show the return type over here. Okay, let's say that's what I want to show, the whole thing. Okay. So the way to do it is, you can see I got another client-supplier arrow over here. It's pointing to the name class, right? I'm showing the supplier being the name. And now, the remind is basically this particular feature. So that means you don't really just show client-supplier on attributes. You can also show on return value, or sometimes even parameter type. It's all possible, okay? So now let's say for remind. Can you help me out here? If I put remind over here, what should I put here as a label? Any guy? Anyone? Anybody? Ken? You mean just dot dot? If you only put dot dot, it's as if you put just name over here. Yeah, exactly. If you only put dot dot, it's not right because remind doesn't return a single name. It's actually an array of name, right? So what you should do is remind over here would be an array of dot dot. That would be a correct way of doing it. Okay, it's a little maybe seem a little bit strange, but get used to it. That's the first time I'm telling you the rule. Okay, I'll stop here, and then we'll continue with this for just about 5 to 10 minutes on Wednesday.